Hello students, welcome to P&M Tuitions online classes. Today in this video we are going to discuss power of lens. So what is this power of lens? And in details about this under this power of lens we are going to discuss about what is the power of convex lens, concave lens and formula for power of lens and units of power of lens. Okay, what if combine the two lenses, what will become power? So let's understand in detail. So as you know, what is lens? First of all, before seeing the power of lens, what is lens? A lens is formed by joining two surfaces. So lens is formed by joining two surfaces. In that at least one must be curve, other may be plane or curve. So depending on that we have two types of lenses main. One is convex lens and a concave lens. And if other surface is plane surface, so we have plano concave, plano convex, concavo convex lenses we have. So here we are going to confine only up to convex and concave lenses. Then what is this power of lens then? So when a beam of light is passes through the lens, what happens? Light is going to deviate its path, right or not? That we call it as a refraction. So now here the deviation produced by a lens is called, it is measured in its power. So I repeat, deviation produced by lens is called, what is that? It is expressed in its power. So here we have what we can say here. So concave lens is deviating light, convex lens is deviating light. So depending on the deviation, how much it is deviating, that is expressed in its terms of its power. So here if you look into the definition, so the deviation of incident light produced by a lens on refraction is called its power of lens. Okay, yeah. Now here what about a thick lens and thin lens? So here a thick lens if you take now thick lens, so thick lens, what will happen to its focal length? It will have short focal length. So what about a thin lens? Thin lens, what will happen to thin lens? Focal length of thin lens is, what is that? Long focal length. So here for thick lens, short focal length will be there, short focal length. And for thin lens, what is that? Long focal length, long focal length. So why this is? Because of the center of curvature. Here thick lens more center of curvature, less focal length. Thin lens less center of curvature, long focal length. So here if you see now, what is that here? So here large, so what about here short focal length? It deviates the rays more. The lens which is having short focal length, it deviates the light more. What about a lens who is having long focal length deviates less? So here that's the reason it is the power of lens. I said already, the deviation of light ray when it is passes through the lens expressed in what its power. So now here thick lens is what it is doing, it is deviating the rays more, and thin lens what it is doing, deviating the rays very less. So that's the reason very less means what here in terms of the focal length. So power of lens can be expressed in terms of what is that? It's reciprocal of focal length. So power of lens P is equals to what is that? Reciprocal of focal length of a lens is called its power of lens. Okay, its power. So here now focal length is in meters. Focal length is, we have to take it in meters. So here again once again I'm repeating. So power of lens is, what is that? Reciprocal of focal length of a lens is called its power of lens. So here now here power of lens is expressed in, so unit of power of lens, what is that? Diopter. So diopter is equals to what is that? 1 by meter. 1 by meter. So 1 by meter. So here focal length we have to take it in a meter. Sometimes in numerical they'll give focal length in centimeters. So you have to convert that centimeters into meters and then you have to find out its power. Now here, so depending on the direction in which the light ray deviates, Suppose if light ray is deviates towards the center, then the power of lens is positive. If the deviation is away from the center, then the power of lens is negative. That means power of lens can be, what is that? Either it can be positive and power of lens can be negative. So when it can be positive, if the direction of the deviation is towards the center, then the power of lens you can take it as a positive. That means for convex lens, power is positive. Then direction of the deviation is away from the center, then the power you have to take it as a negative. That means for concave, negative. So for convex lens, what is that? Power of lens is positive. For concave lens, power is negative. What if you combine the two lenses? So one is a concave and one is a convex. Suppose you have plus 5D, plus 5.0D, power of convex lens is plus 5D, and power of concave lens is minus 5.0D. So what if you want to find out the power of this combination of lenses? What you have to do? You have to sum of these, you have to add the powers of these two lenses, plus 5 and minus 5. What you are going to become? So you are going to get a power of lens as a 0. Power of lens you are going to get it as a, what is that? 0. So when power becomes 0, then lens behaves as a, what is that? Glass, plain glass. So this is what about the thing. Okay, this is what about the power, and from this power of lens you can expect compulsory one question, either units. Okay, what is the unit of power? Diopter. Diopter symbol is what is the diopter symbol? Capital D. So this is what about power of lens, or you can expect a formula of power of lens also. So reciprocal of focal length of a lens is called power of lens. Yeah, so this is what about the power of lens. And compulsory, you can expect one compulsory question, at least choose the correct answer. And for competitive exams purpose also, this topic is very much important. Yeah, thank you.